Okay, I'm going to go over some of this Newton's first and second laws of motion. I'm going to try to make it fast. I'm probably not going to go over all the problems. I highly suggest, if you are still confused about the first and second law, that you go over a lot of this. It will help a lot. A lot of this stuff is just F equals ma. Okay, and then I'm going to skip down to these practice problems, which are just F equals ma, but in a different way. Okay, so this part right here, these words right here are going to be pretty important. Gravitational force, frictional force, and net force. Okay, so let's begin. Oh, I do like the purple. An applied force of 50 newtons is used to accelerate an object to the right across a frictional surface. The object encounters 10 newtons of friction. Use a diagram to determine the normal force, the net force, the mass, and the acceleration of the object, with neglecting air resistance. So, usually I write out a chart of what we have and what we are looking for, but this already has the free body diagrams drawn for us with everything that we're looking for, so I'm not going to do that. But just know we're looking for normal force, net force, mass, and acceleration, and they're all right there. Okay, so normal force, remember, is the force that, like, the surface is applying to the object. So the object is, pushing down with the force of gravity with that force of 80 newtons. And then because of Newton's third law, every action has an equal and opposite reaction. There's an opposite force that the surface is pushing onto the object. And it's going to be, sorry, I don't have my pen today, so please bear with me. And it's going to be equal to the force of gravity that's being put upon the surface, okay? So now we know our normal force, we know our force of gravity, we have friction, we have applied force. Okay, so think about this. These, when we're talking about net force, these two forces cancel each other out because they're the same amount, right? So now we just have 50 newtons and 10 newtons. That 10 newtons is pushing the opposite way of the force that was applied. So if we want force net, we just do 50 minus 10. So you end up with 40 newtons. And don't forget your units. So important. Okay. Now, to get our mass, because we're not going to be able to get our acceleration. We have our net force. We need net force to find acceleration, right? But we can't find our acceleration unless we have our mass. So what we need to do is take our force of gravity. Because if you look up here, the force of gravity has, the acceleration of gravity, which we know, and mass. So since we have this and that, then we just need to plug our numbers in and we can find our mass. Okay, so I'm going to move back down. Okay, so 80 newtons equals mass times 9.8, and that's meters per second squared. That is the force of gravity. I believe it was written up there. 9.8 meters per second squared. So then we're just going to divide both sides by 9.8. And our mass is 8.16 kilograms. Okay, so now we can take our net force, which is 40, our mass, which is 8.16 kilograms, and find our acceleration. So now I've been telling you guys, you don't have to memorize like every version of the force equation. If you just know F equals ma, just like we did in the green right here, you can move stuff around, or you could have it, you know, memorized or rearrange it before you plug the numbers in. That's completely up to you and what you feel most comfortable with. Okay, for me, I'm just going to write it out first. So our net force was 40 newtons. Our mass is 8.16 kilograms, and we are looking for our acceleration. So I'll divide both sides by 8.16 kilograms, so we can get our acceleration by itself on one side. And we're going to end up with an acceleration of 4. That is a 4. Oh my gosh, it's supposed to be 4.9 meters per second squared is our unit there. Okay. All right. Moving along. I'm really going to try not to make this very long, you guys. Let's see. Okay, so for this, number 3, I'm not going to do this one. I'm going to skip to number 4. Oh, number 3 already has the force. Okay, so the diagram for number 3 is on the next page. And then number 4 doesn't have a diagram. So I'll just do that one. I'll just do this one, and maybe I'll do number 5 as well. We'll see how I feel. So this one you have to actually draw your free body diagram. Okay, so and I'm gonna do my my little info chart over here. Get out of the way. Kilograms. So 4.25 newtons. The coefficient of friction . Okay, so let me point you up here real quick. So coefficient of friction, that means we are going to be looking for the frictional force that is applying this way. So we have to find the frictional force before we can have our net force. So you have to do this, you have to think about it in steps, okay? Before we can find our acceleration, we have to know our net force. And to know our net force, we have to know the friction that is going the opposite direction of the applied force. Okay? So we have to know FF in order to know that is an M and it's supposed to be an N, but you get my point. No, you don't. I'm gonna erase it. Okay, so we need net, and then we can find our acceleration. Okay, so now I'll go up here. So let's see, coefficient of friction 0.410. So look at these equations up here. Remember gravity, so that'll be an easy one. Now remember, normal force is the opposite, is equal and opposite of gravity. So we have to find our force of gravity first, or our weight, right? Because that's the same as our normal force. And then we're going to take our normal force, apply by the coefficient of friction, and then we'll have our friction. So, boo, 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 boo. Okay. Dun, 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 dun. I've taken out too much space. So, gravity. So we actually have to look for force of gravity first, then force of friction, then net force. Woo-wee, that's a lot of steps, isn't it? It's okay. This is a piece of cake compared to some of the stuff that I might do in the future. All right, so gravity is going to be our mass, which is 0.675 times the acceleration of gravity. I don't have room to write out my units, but always make sure you're writing your units. I'm going to run out of space because I don't have a stupid pen. So, force of gravity, 7.5. That's what I'm going to round it to. 7.5 newtons. Okay, so that's our downward force. It's also the same as our normal force. So now we can take the force of gravity and multiply it by our coefficient of friction to get our force of friction. And I'm just going to put FF. So 0.410 times 7.5. And that's going to be 3.07. Nope, I'm gonna round that too because I don't want so many numbers. 3.08 newtons. Okay, so now we have our force of friction. That's the one that's going this direction, and it's pushing against our applied force. So what we need to do is subtract them to get our net force. Switch colors. So 4.25 minus 3.08. So our net force is going to end up being 1.17 newtons. And our force of friction. Okay, so now we have our net force. Net force is what we need to get our acceleration. Because now we've calculated everything. We've got all our forces in play, right? We have our friction pushing against our applied force. So the book is being slowed down as it's being pushed. So, or after it gets pushed. So now you can calculate your acceleration. So let's see. Acceleration is force net divided by mass. So 1.17 divided by 0.765. Sorry, I'm running out of space, so I can't write that down. But 1.52. 53. Whoa. Oh, what just happened? That's a 3. Meters per second squared. Okay. 1.53. We had to do all those steps to get to the acceleration. Luckily, for our quiz tomorrow, you won't have to do anything quite so complicated, but it's good to know for the future. It will come in handy. Okay, this seems kind of complicated because we're talking about a pulley system. But in reality, it's just, you can draw just the same. So, low friction track. Let's see. Use a hanging mass and pulley system to exert a 2.45 Newton rightward force So there's my cart, and it's 0.5 kilograms. The applied force is 2.45 newtons. If the total resistance force, so resistant force is going to be going the opposite direction, our force of friction in this case, even though it says it's a low friction track, which I guess 0.72 isn't too bad. 0.72 newtons. What is the cart's acceleration? So we're looking for acceleration. This one's way less steps than all the other problems. So you just need to find your net force. So 2.45 newtons minus 0.72 newtons. Okay. So that's our net force. Now that we have that, we can set up our equation. F equals ma. Newtons equals our mass, which is 0.5 kilograms, times acceleration. You have to divide both sides. And our acceleration is going to be 3.46 meters per second squared. Okay. I hope you guys found this helpful. And yeah, make sure you study. Study. 20 minutes and get your homework done.